All right, good morning, everybody. So today, kind of want to go off the path that we were headed on yesterday because it didn't look like we were going to get as far as I had hoped. So what I want to talk about today are some other objects and compound shapes. Okay, so the other objects that I want to talk about are trapezoids and parallelograms. Now we're going to spend a good amount of time on these shapes later on down in the next couple of weeks. But I'm pretty sure you've seen these two shapes before. And without getting too technical about what they are, I'm not going to dwell on that so much. You can kind of think of a parallelogram as a rectangle that's kind of been pushed over. Okay. If you've ever broken down a cardboard box, you might know what I'm talking about. Okay. And in a parallelogram, you've got two pairs of parallel sides. You got parallel sides up and above and below, and you have parallel sides on either end. Okay. And like I said, we're going to spend plenty of time talking about the properties of parallelograms. But right now, I just kind of want us to be reminded of what they look like and what some of their basic, like finding the areas. That's really what we've been working on. Okay. And a trapezoid, I think you've all also seen, a trapezoid is made from two pairs of parallel sides. Now there's the other two sides, they can be the same or different, but if they are the same, and I'm going to give you an example of that. One moment, it's hard to draw sideways. Let me just draw it and put it back. Hold on. I want to make sure it looks right. Okay. Okay. So both of these are trapezoids because they've got one pair of parallel sides. But as you can tell, these two sides are different, and that's okay. But when the two sides are the same, if they're the same length, this one has got a special name. It's called an isosceles trapezoid. And you can kind of think of it, and if you'll just let me turn this upside down for a moment, you can kind of think about this as like an isosceles triangle that had the top chopped off. Kind of like that. Okay. You know, something that looked like an isosceles triangle. And then I just chopped off the top. And you would have a shape that looks like that. Okay. But like I said, we're going to spend a lot of time talking about these in a couple of weeks. Probably next week is when we're going to really start messing around with their properties and things like that. But right now, it's just important for us to know what they look like. So we're going to talk about their areas because we're going to use them to make three-dimensional objects. Okay. So I wanted to first talk about a parallelogram. Okay. So if I want to find the area of a parallelogram, what I have to do is there's two pieces of information I need. I need the base I need that length, which by the way is the same as that length. Okay, these are the same. Okay, so if that's 10, then that's 10. Okay, so remember, think about a rectangle. You start with a rectangle and you just go whoop off to the side. Okay, like I said, if you've ever broken down a cardboard box, and if you've ever taken a cardboard box and you take off the tape and it'll fall off to its side, like that. That's the same idea. Okay. And I also need the height. Okay. So the formula for the area of a parallelogram is the base times the height. That's it. It's a lot like length times width. Okay. And in fact, it's exactly the same as length times width. Okay. Because let's take my I'm going to do a, first of all, everyone copy this down because I want to use another piece of paper really quickly. Okay. Give me a thumbs up when everyone's got this picture copied in the formula. All right. So I'll do this with another sheet of paper. Okay, so I'm going to make a parallelogram. Okay. So I have a parallelogram. Now, I said that the formula was the base times the height. So I'm just going to go ahead and draw the height. Okay. And that this formula is exactly the same formula as the formula for the area of a rectangle. And here's why. If I take my parallelogram and I cut off this triangle, I still have the same amount of paper. I just cut it. And then I take this over here. Now, let me just get a piece of tape so that it looks right. No, it's not the best tape job, but I think you get the point. I've got a rectangle. Okay. And so the area of this rectangle is the base times the height, or length times width. Okay, so the area of a parallelogram is the same as the area of a rectangle. You just need the bottom, you need how wide it is, and you need to know how tall it is. And there you go. Okay. So these formulas they're not magic. They're based upon other things we know in math. Like, for example, in this case, the rectangle. Okay. So just so that we can do this, if I told you How about this? I will make parallelogram. And I'm going to tell you this. This is 6, this is 10, and this is 8. Okay. So if I gave you this parallelogram, first of all, how big is the base of this parallelogram? Actually, I'm going to change one of my numbers. I'm going to make this a 10. So how big is the base? It's from here to there. Okay. A couple people in the chat. That's good. So the base goes from here to there. So it's 6 and then 10. Okay, so I'm going to pause the recording for just a moment because I want to talk to the class for a moment. So how big is the base of this parallelogram? Put your answer in the private chat. All right, that's great. Much better than before. So now we need to find out. So I'm going to write that down. I'm going to say that my base is 16. I got that under control. Now we need to find the height. And I don't have it, but I do have this information here about this triangle. And it's a special kind of triangle. It's a right triangle. So do we remember how to find the side of a right triangle? We had a formula for that. Great. It's got that big long name that starts with a P. Thank you, Cynthia, for saying that. That is the Pythagorean theorem. So let's use the Pythagorean theorem to find out how big this side is. We'll set up an equation. This is the hypotenuse, so it's going to be all by itself. And these two parts are the other sides of the legs. So 6 squared plus h squared. Go ahead and solve that Pythagorean theorem problem, please. Find out what h is. Okay, good. A lot of great answers. So 36 plus h squared is 100. H squared is 100 minus 36. H squared is 64. So h, remember you got to square root both sides, is 8. So now I have my height is 8. So now find me the area of the parallelogram, now that you know all of this. Okay, so 16 times 8, plugging the b and the h into the formula. The area is 16 times 8, so the area is 128. Okay. All right. So now, that's great. So now let's talk about a trapezoid. The area of a trapezoid. So in a trapezoid, and it can be any kind of trapezoid, okay, we have the length, this is parallel. We have the first base and the second base. We have two of them. We have these two different lengths. And we have the height. And the area of a of a trapezoid is the height divided by 2 times the sum of the two bases. Now, let me show you where that comes from, because that looks like it's magic, but it's really not. All right, so I'm going to take this piece of paper and I'm going to fold it in half. Okay, folding it in half. Now, I'm going to make a trapezoid. Okay. So I have my trapezoid, and since I folded the paper in half, I've got two trapezoids that are exactly alike. And what I'm going to do is I'm going to take one of them and I'm going to turn it around. And now what do we have? What shape is this? Yeah, now I've got a parallelogram. And the formula for the area of a parallelogram we just talked about. So I have a height and the base. Now the base of this parallelogram is this long one was base 2, and this short one was base 1. And it doesn't really matter which one you call which. So what we have for the area of this whole thing is the bases, base 1 plus base 2 times the height. But this is not the shape that we want. We want just one of them. And since I doubled it, this number right here, that if we were to crunch it, would be 2 times as big as I really want it, because I really just want one of them. So what do? I multiply it by 1/2. So that cutting it in half, dividing it by 2. And you can see that this divided by 2 is that, and base 1 and base 2. So the formula comes from the area of a parallelogram. All right, great. So do this one for me. Find the area of that parallelogram. And I will use inches. So please put your units on this thing. Remember to do the math inside the parentheses first. Okay, so let's go in here and take a look. Plugging in the height, which is 5. And it doesn't matter which one of these is the base 1 or the base 2, because you're going to add them up anyway. So order of operations says to add these two first. And you get 28. Now, you can put this in the calculator pretty much any way you want, because the order of operations is all the same on this one. It's multiplication and division. Okay. But if you wanted to, 5 divided by 2 is 2.5 times 28. And that is 70. And since it's in inches and it's an area, your answer is in inches squared. Okay. Let's do one more of that. Okay. So you got to look at this one kind of carefully to see who is who. Remember, your area is the height divided by 2, base 1 plus base 2. And you might need to turn this on its side for you to see what is what. See, so now that I've turned it on its side, you can see who is the height and who are the bases. Okay. So find me the area of this trapezoid, and I'll make these meters. Okay. So my height is the 10, and the two bases are of the 11 and the 5. So, and 10 divided by 2 is 5, and 5 times 16 is 80. This is an area, so I need meters squared. Okay. Okay, this one was a little weird because, like I said, you had to kind of turn it in order to see who were the two bases, this one and this one. Okay. And I know that they're parallel because they're both right angled to the same side. Okay. Kind of like a rectangle, right? Okay. So now what we're going to do is find the area of a parallelogram that is a prism. Right. And I'm going to tell you that this is 10, and this is 12, and this is 14. Okay. Now, it's a prism, and we've talked about prisms. So the volume is the base of the prism times the height of the prism. So the 12 is the height of the prism. And this piece right here is the same as the one on the bottom, right? And so I need to find the area of this. And by the way, I'll show you what one of these things looks like, by the way. They look like this. It's got a weird special name. This is called a parallelepiped. And so the area of the top times the height gives you the volume of this. It's good questions in the chat. Is the height always going to be next to the right angle? Yes, the height has to be at a right angle to the base. Okay. And there was another question, can I do another parallelogram problem? We will right now, actually. We have to find the area of this parallelogram. So the area of that parallelogram is the base of it, and let me do a color. The base of that parallelogram times the height of that parallelogram. And you can always tell who are the base and the height because they're at a right angle to each other. Okay, so this long green line, how big is that long green line? Right, 14, good. So 14 times the height of this parallelogram is 10. So this is 140 for that one. And so that is the base of my prism. And now I need to multiply that times the height of my prism. So my volume is 140 times the height, which is 1,680, I believe. And since it's a volume, I should say, and I don't have my units listed, so I'll just say units cubed. All right. We have time for maybe one more really quickly. My picture's not so great. So this is 10. This is 6. The height is 5. And this side is 12. And so I've got a trapezoid that's been made into a prism. So the volume of all prisms is the base times the height. So we have to find the area of the trapezoid. And what's the height of this trapezoid? Sorry, the height of this prism. This number right here, this H right here. What's that? How tall is my trapezoid? Right. Say it. You were right.
10.
Oh, well, you're right. The height of my trapezoid is 10. You're right. But the height of the prism is the 5. But now I have to find the area of the trapezoid. And inside the area of the trapezoid, the height of the trapezoid is the 10. And my base 1 and base 2 are the 6 and the 12. So now six plus 12 is 18, and 10 divided by 2 is 5. 5 times 18 is 90. And so now I can stick that 90 up into the big formula. And the volume is 90 times 5, which is 450. Okay. All right, so we'll pick this back up tomorrow. Everyone, remember there are IXLs you need to be working on for homework. Please get to working on some of those. I'm seeing only a handful of you working on those. We need to get moving, all right? It is for a grade. Have a great day, everybody. I'll see you tomorrow.
Have a good day.